Now we're gonna use a different approach. We know that this triangle produces this set of ratios down up here and down here, depending on the angle we're using. So let's say I'm doing the tangent of 60. So if I use tangent of 60 degrees, it is the opposite, meaning x times the square root of 3, or simply use any value. If you multiply this by 1, you get the square root of 3, and if x is 1, you can write it like that. So instead of simply writing x times the square root of 3, you can just write the square root of 3 divided by 1. If you do it like x times the square root of 3 over x, you're going to cancel those out, and you still get the square root of 3. So that is the relation, the ratio between the opposite and the adjacent. So that relation has to be true for this triangle as well. So if tangent of 60 degrees is equal to the square root of 3 over 1 for the first triangle, it has to be true for this triangle as well. So tangent, let me use a different color, one that matches the triangle. So for this triangle down here, I can also say that tangent of 60 degrees has to be equal to the opposite divided by the adjacent. So I can say 4 divided by b. And I can simply substitute the value that I already know from the original triangle where I have the ratios. So I can say the square root of 3 over 1 has to be equal to 4 over b. So what I'm gonna do now is I'm gonna solve for b. So I'm gonna cross multiply, ending up with b times the square root of 3 equals 4 times 1. And if I solve for b, I'm gonna get b is equal to 4 divided by the square root of 3. And if I rationalize this answer, meaning 4 over the square root of 3 times the square root of 3 over the square root of 3, I get 4 times the square root of 3 over 3. So 4 times the square root of 3 over 3. So that means that this side is 4 times the square root of 3 over 3, just like we saw on the previous example. And this side will be 8 times the square root of 3 over 3, because you always have to multiply by 2, whatever the length of that side down there is.